Payment systems are not about charging cards. They are about correctness, safety, and reconciliation. When I think about payment system, I start with the real job, an e-commerce checkout that must capture money exactly once and keep order state correct under retries and asynchronous updates. Before we pick components, be clear about the workload. This design has to handle payment flow, gateway integration, orders, transactions, idempotency keys, webhooks, refunds, fraud checks, audit logs, reconciliation, and security, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually the web application charges the card directly and marks the order paid immediately inside one synchronous request. I still start simple on purpose. The smallest version that can work here is the web application charges the card directly and marks the order paid immediately inside one synchronous request. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next: duplicate requests, delayed webhooks, and gateway ambiguity. Create correctness bugs faster than performance bugs. The first production pressure usually shows up here: duplicate requests, delayed webhooks, and gateway ambiguity. Create correctness bugs faster than performance bugs. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic, that pain looks like refunds, disputes, and fraud controls need durable transaction history and safe state transitions. And then comes the part junior diagrams almost always skip. Finance and support teams cannot trust the platform unless reconciliation and audit trails are built into the design. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is a dedicated payment service with transaction records, idempotency keys, gateway coordination, webhook verification, refund flow, audit logs, and reconciliation jobs. This is what you gain from the stronger design. You protect money flow, customer trust, and operational accuracy by treating payments as a state machine instead of a button click. Those gains are why the extra complexity is sometimes worth it, but there is always a bill to pay. The cost of the stronger design is the system becomes more explicit and slower to reason about, because every state change has to be verified and recorded carefully. That trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask what happens if the user retries, the gateway times out, the webhook arrives late, or the order service is unavailable after the charge succeeds. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Trace checkout through payment intent creation, idempotent charge handling, webhook confirmation, order update, refund path, and reconciliation. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers learn the critical design concerns behind payment reliability and correctness. Good system design is a judgment loop, not a memorized answer key.